This video shows the basic concept of creating a car battery which longs for about 35,000 miles with one charge of the battery. So this is let's say an amount which is incredible at the moment, and where most people will laugh and say, okay, this is absolutely stupid, but it's not. And at the moment those batteries are not available, but I will show you how this would work and what mankind would have to do to create those batteries. The battery itself is based on a very old idea or experiments which are at the beginning of electricity, before there was those galvanic elements and the common galvanic batteries. There was always those experiments with this Van Graaff band generator, where there was where they had some cat felt and some stuff where electricity was produced. Okay, and they had some small flashes on that. This was a Van Graaff generator. And what does the Van Graaff generator, and what was the basic idea of this? Let's say first come to the first basic thought was, when nature creates, whenever I see bad weather, a cloud, and see those flashes going down, then I know this is the energy stored in the clouds with positive and negative energy is happened by ionization of water molecules which will be run up and down by speed, and they are, let's say, the charge is rubbed or crashes the molecules, or not crash, but it steals electrons and discharges those molecules. So I thought to myself, would it be possible to do the same thing for mankind with a battery? So I started to calculate that stuff, and this is when you calculate that stuff, this is called, when you take, for example, the carbon atomic module, then it's called ionization energy. And this is in those times, in around 1900 and something, they calculated this the energy which was called the first ionization energy. So the atomic model was done by Niels Bohr, 19 something, and soon after this, when chemistry and all that stuff was improved, then they as soon as this was, they also calculated the energy which is necessary to when you have an atomic model, when you steal one electron out of those shells, and so you will get a positive ion and a negative ion. Negative one is the electron itself, and this one is positive because there's a difference, there's missing one electron. And when they calculated all that stuff, they found out, this was done, I think, by Corona energy. I don't know the English word about it, but it's the first energy to steal an electron from that stuff, and simply steal it. So you need 1000 kilojoules per mole. Mole is the amount of atoms in a specific, let's say, mass or a volume. And now when you take this this formula and insert this formula into a general system, and when you come there to, when you calculate it on, let's say here, on a Tesla car, and you take the weight of a Tesla battery and transpose that stuff into the real ionic carbon ions, then you will need 91 megajoule per kilo, and therefore for the entire battery you need, what was it, the Tesla is 400 kilograms, and you will need for this 36,000 megajoules. So this is 50,000 kilometers, or 35,000 kilometers miles for the first ion, which you rub from the atomic model, from those stuff. And when you take all that stuff, all those ions, when you rub that stuff and push them into a cylinder, for example. Now, in the former time they did it with a Van Graaff generator, and most people had that module, this demonstration stuff in school in Germany. It's in the 10th class. And I'll show you on, have first a small look on that on YouTube. There are a lot of those generators there, how they work. Let's see. This is the German, in the German museum. But now here's one. You will see the flash which go there. And now this is a bulb, and this bulb ionizes some molecules by corona discharging, and those runs up into this in this pole, and they stay there. Now this is explained. The Van Graaff generator is explained here in a little bit more. So you have a roll there, and triboelectric effects, all that stuff, and it shows as this works. And those ions, those discharged and charged ions, they are always finally here on this top dome. And on this dome, when you take those, simply by that theory, when you take those molecules and dump all that stuff into a cylinder, mechanically by an engine and a belt again, it's not only for joke and for demonstration. When you take that stuff and move it in there, then you need a little bit of more power to do that, but it's still the same. It's just dislocation, and those molecules don't want to be here in the inside one big cylinder, but they will do when you push it on there. So the voltage on that grows up to 10,000 volts, and even more, 20,000 volts. But when you do that, you will get a superpower battery which has high voltage, so super high voltage. When you have an actual battery, you have around the galvanic battery. Then you always have, where is it here? You have small voltages, which are, let's say, in parallel. All that stuff in parallel. All molecules are in parallel, and they have a lot of small power, and they are bound in a bigger molecule. So this is, what is the English word for it? I don't know it. Bleisulfid. I don't know what the word in English is, but there are always molecules from one level. They go to another level with another contract. And the difference is those, let's say, 1 or 2 volts, and those are accumulated to a higher voltage. They are switched in serial, but it's always that they have a small voltage. It's from one binding to the other binding. Now, when you go just another way, when they created electricity and battery, so when the first galvanic battery came up, then it was not at that moment the belt generator was not necessary anymore. So because there was no need for it, and the low power is super convenient. But now when we create cars in a new generation, we need long distance batteries which are more above than let's say 500 kilometers. So let's have a general look on that stuff and say, hey, why are we not using this super high power, dumping all that stuff into a container, and then we should, in this point, we will get ultra high power. But that's the same as when you have an actual battery and modify it up in serial by 470 volts, for example, on the electro racing cars. When this battery container crashes then also the machine will burn down. In this case, but it's always only on 470 volts, or let's say 1 volt, 10, 12, 50 small voltages. In this case, we would have real 100,000 volts and multiplied by electrons. So this is a super high energy battery, and this super high energy battery has to be created by modifying this Van de Graaff generator, where you have these molecules which will be dropped here inside the top dome, and you have to move it in a base containment. Now this battery is very dangerous, but in the future it should be necessary to create one of those batteries. That's my suggestion. Now I didn't find anybody who would help me at this point, because you know, I'm a simple electro technician. No, not technician. I studied it. I was in IBM for my first years, and the business world is very difficult in this point, and you need for doing that stuff. I made some small experiments with liquids, running liquids, where the stuff should happen the same way like in the clouds, but you need let's say around 5 years to make a basic experiment where you move this stuff into the container. Very simple. So it would be necessary to have, let's say, a startup business which is based on, let's say, 500,000 euros or something like this. And at the moment I don't find anybody who will invest in that. That's the point. I'm pretty sure that this would work, and I know that it sounds sometimes ridiculous and people think it's not possible, but since nature does also behave in this way, and mathematics and chemics gets this structure, it should be possible. And I hope on this way that I will find some contributors, some people who support me and will contact me, and maybe we make a startup for this point. I would be pleased to help you, or you do it, because the future of mankind would need some some basic machines running on that stuff, which is super high power.